Hi, I'm Ken, and this is Under the DUT, where we talk about devices and applications that excite us. We're going to talk to Bryan, who's an application engineer friend of mine, about what it takes to get to a device like this. So let's go talk to Bryan. Hey Bryan, thanks for being here.
Good to
Really
be here,
appreciate
Ken.
it.
Mm-hmm.
So, I have my thermostat. I pulled it off the wall, and I wanted to talk about what does it take to actually get to this device.
Right.
And I thought we'd go ahead and take some time and discuss from the perspective of, how do I design it? How do I prototype it? And what kind of considerations do we need to address for manufacturing?
Yeah, we'll kind of peel back the curtain a little bit on what goes into engineering this.
Yeah.
And this is a fun device because I think the whole smart world or smart home is kind of blowing up, and the smart thermostat is really one of the first steps to a smart home.
So where would I approach designing something like this?
So generally on a design, we're starting with a block diagram. We're looking at our inputs and our outputs. So what do we want this to do? We want it to control the temperature of our house, obviously, right?
Yeah.
And we want it to know when to control that temperature.
Well, it knows when I came home. I mean, it went ahead and switched over to another program.
That's exactly right. So that's stage one, is how do we know when you're home? There's a few different ways to do this. Back in the day, they used to use ultrasonic sensors, which is kind of sound waves, and if it bounces off something, we know someone's home.
Okay.
That's a little primitive. It's not so accurate. So nowadays they use something that's called passive infrared.
Okay.
Or PIR, you'll see it used as sometimes. So this little guy right here, that'll have a passive infrared sensor in it. And really, it's tuned to body temperature. So you'll have a couple of them, and that helps gain confidence, right? Because maybe you come in through the back door as opposed to the front door, and so the sensor will be able to pick that up. But from a design perspective, there's still things you have to consider, even when just picking out that sensor. If you have like a little kind of skinny frame of view, do you need a wide field of view to really be able to tell?
So Bryan, once we kind of have this kind of block diagram of what we want and what do we want it to do, what's the next stage? I would assume we go ahead and pick out some components, kind of throw them on a board and try to make it do what we've designed for.
Definitely. Okay. Yeah, so that's my favorite part, and that's what we call the prototyping stage. So we get our microcontroller, that's what we're going to use for the brains, and that's kind of, it's a computer, but it's a little more passive, low power, and it's an embedded system that needs to do one specific thing. But then there's onboard sensors that are going to use more like a serial communication. So I2C is really common.
Okay.
That's what I've used in my embedded projects, but there's SPI, there's RS-232, there's a lot of different flavors to do the same thing, which is communicate efficiently. But when we're prototyping, in a perfect world, we put all our sensors and our microcontroller together and it works and we're happy dandy and that's it. But in the real world, stuff goes wrong. Our I2C communication doesn't work, our power levels are too high or too low. A big one with Wi-Fi that's difficult is you can't see it.
Yeah.
Is there interference? Where's the interference? How do I change it? And then from a design perspective, you want to know the margins. So not does it work, does it not? But how much wiggle room do I have here? Like if I were to downgrade my sensor, am I still okay? Or if I was in a noisy environment, or there's just a whole spectrum, for lack of a better term, of things that can go wrong.
Right. I expect that that would be very important with any peripheral devices like this remote sensor, that I'm not too far away from the base.
Right.
In order for it to work.
And that takes us into one of my favorite sayings is, if you can't test it, you can't improve it. So I can just tune my spectrum analyzer to 2.4 gigahertz, and I'm looking at all the communication that's happening on. Similar to the I2C bus, it's been around long enough, and people have used it enough that you can hook a scope up to that bus and dial in your settings of your data and your clock, and we'll look at exactly what's being communicated. So my motion sensor's telling my controller to turn the heat on, the heat's not turned on, what's going wrong? Well, it's coming over Wi-Fi and it's getting there. Okay, so we're good on that, but it's not getting communicated back. So maybe we look at that bus and see if it's sending the go or no-go type of thing.
In the frame of putting it into the prototype, I'm also swapping out the different types of test and measurement equipment to do the specifics.
Right. Power's big because power is not always available, or If you want something to last a long time, you don't want to be replacing your TV remote control batteries every week. So having a battery simulator or a source measure unit, let's say, where you can actually run that control and see what's going on there. Because it's going to depend on which components you're using, how power intensive they are, if they go into a low power mode. That's part of the prototyping process. But once we know that it works and we have the components we need, right, we need to package that up and into a nice little sleek design like this.
Shrink ray.
Shrink ray. And then in production, things are going to go wrong because you're mass producing them. Maybe it's robots building it, and so we want to test some of that and mitigate some risk, so we're not doing recalls or things along those lines.
Thank you, Bryan. I really appreciate you coming by and talking about my smart thermostat. There's so many things that we could talk about with regards to Internet of Things devices. Please go ahead and put in the comments your ideas of what we could cover that would be meaningful to you. Things that excite you, devices, applications. Also, if there's something that we discussed today that is something you'd like us to go deeper into. Bryan's got some technical background. He's an applications engineer. He does this stuff. We would love to go ahead and continue the conversation with you. Thank you very much for watching.
Thanks, Ken.